So in the last unit, we have been working completely with expressions. And we worked with algebraic expressions that had variables in it, but unless I told you what the variable was, you didn't know what it stood for. Now in this unit, we're going to be working with equations. And once you have an equation, you can usually figure out what the variable is. And we're going to start learning how to do that today. So go ahead and turn to the Do Now, and we're going to review those answers. All right, here are the answers to the Do Now. And really, these were about kind of guessing what this number would have to be to make this statement true. So for example, this side adds up to 17. What do I need to add up to 8? Add up with 8 to get 17. Of course, that's 9. So this was kind of guessing and checking, and you're going to see as we move through this unit that we don't have to guess and check anymore. We're going to have regular mathematical ways to do this. And for number 2, again, we have some keywords: 5 more than the product of 3 and a number. So that than tells us this goes first. So we have the product of 3 and a number, that's multiply. And then 5 more means plus 5. All right, go ahead and turn to the next page, please. So let's talk a little bit about what an algebraic equation is. So here's an example. X plus 5 equals 8. Pretty simple. And an algebraic expression is when we set an expression equal to something. And that's what we've done here, right? We've taken an expression, x plus 5, we've set it equal to 8. Now, when we solve an equation, and that's what we're going to be doing a lot today, when we solve an equation, we find the value of the variable that makes the number sentence true. So you did that in the warm-up a little bit, and even this one's a pretty simple one, right? You could figure out what x would be, what plus 5 equals 8. Most of you would be able to figure out that that's 3. So there are more mathematical ways to solve that, again, than guessing, but we'll see that more of that tomorrow. So just to recap, an expression, right, has no equal sign. No equal sign. And it might look like something, let's say 3b minus 2. An equation has an equal sign. So you could take 3b minus 2 and set that equal to something. And now you have an equation. So here's an expression all by itself. Here's an equation with an equal sign. All right, so here's the thing. Solving equations is all about balance. Because there's an equal sign, we need both the left-hand and the right-hand side to be the same. So you're going to see lots of pictures of balances, and this kind of looks like a seesaw, but it's level, so both sides have the same value. And that's the way we need to think about this. So an equation means both sides are the same, and we're going to figure out what we need to do to make both sides the same. All right, so in the example from above, of course, we know that to make both sides the same here, that x would have to be equal to 3 for this to balance, right? Otherwise, one side will be more than the other or less than the other. All right, so let's take a look at examples. Please turn to the next page. So we're going to look at examples that are dealing with gold coins and bags with gold coins inside. But the trick is we don't know how many coins are in the bag, and that's what we're going to be figuring out. So if the balance is level, like this is in this example, then both sides of the balance are equal to each other. So you want to write that in here. And we're going to use the variable b to represent the number of coins in the bag because it's unknown. So we're going to be writing an equation based on this balance, and then we're going to figure out, just by using a little bit of common sense, what the number of coins it has to be in that bag. So the first one is a really simple one, right? On the left-hand side, we have b, and on the right-hand side, we have 1, 2, 3, 4, 5, 6 coins. So our equation is b equals 6. And of course, that's an easy one because then we know that there has to be 6 coins in that bag for them to balance out. All right, so that's a super easy one. But then it gets a little bit trickier with this next one. So here on the left-hand side, we have some unknown number, and then we have 2 additional, and then once again we have, looks like 6 on this side. So we know that we have b coins in the bag, we have an additional 2 outside the bag, and we know that that's equal to 6 coins on the right-hand side, right? This has to be the same as this. So then, if you look at b plus 2 equals 6, what would b have to be? And of course, we know that 4 plus 2 is equal to 6. And that's the idea. You're trying to write an equation to represent this, and then figure out from the equation how many coins have to be in the bag. All right, let's go ahead and turn to the next page, and you can try some of these on your own. Let me just say a little bit about some of these problems. Some of them are going to have more than one bag, and in this situation, assume that they have the same number of coins in each one. And you could think of this as b plus b, but we're going to use multiplication when you have more than one bag, so we would actually consider this 2b, or 2 times b. All right, so I'm going to have you pause the video and come up with the equations and the number of bags, number of coins in the bag, and then come back and see how you did. All right, check out these answers. The first one was pretty straightforward. This one, we have 12 on the left-hand side. We have 2b on the right-hand side, so you have to think about 2 times what equals 12. Of course, that is 6, so we know we have 6 coins in each bag. And then this last one, again, we have 10 coins on this side, and we have 1 bag plus an additional 4 coins on the right-hand side, and we have to figure out what plus 4 is equal to 10, and again, that number is 6. So notice that I put the 12 and then the variable on the right-hand side based on where they were on the scale. But you could do either way, actually. It doesn't actually matter. You can switch either side. I could have had 2b equals 12. All right, go ahead and turn to the next page for some more practice. All right, these are just a little bit trickier, and I'm going to let you pause the video and work on these, and then come back and check your answers. All right, check out these answers. On the first one, we had 15 coins on the left-hand side. We had 2 bags plus 3 additional ones. And then I had to be a little bit clever here. I had to try a couple of numbers to figure out what it would be. I thought maybe 5, but 2 times 5 is 10, plus 3 is 13. That's not quite enough, so I tried 6. 2 times 6 is 12, plus 3 is 15. So I knew the 6 was the correct answer. Again, you have to do the multiplication first here because of order of operations. On number 5, we have 9 coins on the left-hand side, 3 bags on the right-hand side. So I had to figure out 3 times what is 9. Of course, that gives you 3 coins in it. All right, so let me know if you have any questions, and we'll do have you met your target at the end of the class, and if there's some time, you can start working on your homework.